Mr. Wilson?
Yes.
How you doing? I'm Mike with Proctor.
Hi.
Here to do CheckMe.
Great. Come on in.
Hi, I'm John Proctor, President of Proctor Engineering Group. And for some of you, it may have been a while since you've done a CheckMe run, so we'd like to run through one real quick with you, show you how it can be done in less than 25 minutes and hit the key points. So with me today is Mike Sims, Master CheckMe Trainer. So Mike, why don't you start the watch?
Can do.
The clock's running and Mike has moved to the inside unit. He's determining the refrigerant metering device, whether it's a fixed metering device or a TXV. If it's a fixed metering device, we'll use superheat to determine the refrigerant level. If it's a thermostatic expansion valve, then we'll use subcooling. This unit has a TXV. We want to do this procedure fast, but we still have to get the unit to steady state. And that'll take 15 minutes of runtime. So you go to the thermostat right away and turn it on to start the 15-minute runtime. You could also jumper it from the circuit board. The 15 minutes will give you plenty of time to set up your instrumentation and anything else you need to do. Mike is hooking up his gauges to determine the high side and low side pressures, as well as the evaporator saturation temperature and the condenser saturation temperature. As you know, to get an accurate diagnosis, you need the correct numbers. Therefore, your gauges need to be calibrated as shown in the CheckMe manual. You need to do this before you leave the shop. First, let your pure refrigerant tank set at room temperature, and then tape a thermocouple on the tank. After you zero your gauges and attach them to the tank, and open the manifold to get the pressure to both the high side and the low side, both the gauges should read the same number, and it should be the appropriate temperature for the refrigerant in the tank. Your digital thermometer also needs to be calibrated. Place a good thermocouple in the middle of a phone cup of stirred ice water. With the thermocouple plugged into T1, that channel should read 32 degrees Fahrenheit. Adjust the offset screw just below that to 32. Switch the thermocouple to T2 and adjust that channel to 32 as well. Don't adjust the offsets after that. Now test the rest of your thermocouples. They should all be within 1.5 degrees of 32. Next, you place the thermocouples on the suction line and the liquid line. These clamp-on thermocouples are nice and accurate. The last thermocouple you install is to measure the condenser air entering temperature. Remember, this is not the temperature reported by the guy on the radio, or the temperature under a tree, or by the pool, but what is actually entering the condenser coil. This is a good time to record the make and model of the air conditioner. Mike is drilling the holes for the return, wet, and dry bulb sensors, and the supply temperature. As you can see, this is a downflow furnace. So Mike, you used a couple of minutes of your 15-minute runtime. What are you going to do with the rest of the time?
You could check the voltage across the contactor. That'd be a good thing to do. Another thing I like to do is check the amperage at the compressor, see how those windings look. And the third thing you should definitely do is check the condensate line because you don't want any flooding in the house.
Okay. Before the 15 minutes are up, you'll need to insert the wet bulb sensor. That's the one with the cotton shoelace. If you insert it too early, it'll dry out. So at about 13 minutes, you wet the cotton shoelace, put the wet bulb and dry bulb sensors in the return plenum, and watch as the wet bulb temperature drops. When it's stable, that's the number you want to record. Mike is now taking pressures and saturation temperatures from his gauges. He then notes the suction line temperature, the liquid line temperature, and finally, the condenser air entering temperature. We are looking for an accurate diagnosis of the refrigerant charge and airflow. For a fixed metering device, correct charge will be indicated by a superheat within 5 degrees of the target from the superheat chart. Remember, the target superheat varies with the condenser air entering temperature and the return wet bulb. For a thermostatic expansion valve, correct charge is indicated when the subcooling is within 3 degrees of the target. Airflow can easily be checked using temperature split. Too high a temperature split is a sure sign of low airflow. Now that we have our numbers, it's time to call CheckMe toll-free.
Hi Elaine, this is Mike. How you doing? Good, I've got a CheckMe run for you.
When you give the operator the data, she'll enter it into the computerized expert system. At that point, the CheckMe program analyzes the figures and what it will take to optimize the system. Here at Procter Engineering, we're committed to taking your call right away. No put you on hold, no stupid music, no press 5 or 6 or 7. You get a real human being right away, and the average phone call is only 2 minutes and 53 seconds.
And your numbers, please. 101, 64.
Depending on the calculations, the operator will let you know the status of the unit and what, if anything, you need to adjust. Of course, when you need to make adjustments, you'll call back in and confirm the final numbers.
Okay, your unit is charged correctly. Your actual subcooling is 10. Target is 12. The airflow is low. Actual temperature drop is 26. And target is 19.5. Thank you for calling CheckMe. Bye.
Well, it's been less than 25 minutes since we started the testing. We know what's going on with the air conditioner. We know what it'll take to optimize it. And we can sit down with a customer and tell them what needs to happen next. I'd also like you to think about what it takes to integrate this into your normal practice. For example, you can really speed things up on houses that have multiple air conditioners or rooftop commercial units by having 2 sets of instruments. So you can set up one, get it started, move to the second one, set it up, go back and take the measurements on the first one, then move and take the measurements on the second one. That, of course, cuts the time in about half.
We did find that your refrigerant levels are very good. They're right where they should be for that system.
Before you leave, let the customer know they will be receiving the certificate. It will say exactly what happened, so talk to the customer. Make sure they know if anything still needs to be done.
There's an airflow issue here, and I mean airflow through the evaporator coil in your air handler. And part of that problem is your filter's a little dirty. So this is a pretty common problem in residential. I would highly recommend cleaning this on a monthly basis, and that should take care of that. So that's an easy fix.
After the data is analyzed, a certificate is printed and sent to the customer. This is a great tool for you.
And it'll state the results of my findings from a third party to make sure that everything's looking good and that my...
So in less than 25 minutes, we've done a complete and accurate diagnosis of the air conditioner with CheckMe. We've also shown you how to fit CheckMe into your normal procedures.